Welcome to lesson 3-2. Today we're going to be talking about solving addition and subtraction equations. So basically we're going to have an algebraic equation. So that means there will be an equal sign and there will be a variable. But we're going to be working on solving for these variables. Now in order to do this, we have two rules that can help us isolate our variable or get our variable by ourselves so we can see what it's equal to. So the first rule is a subtraction property of equality. Now this basically means that if you subtract the same number from both sides, your equation will still be balanced or equal. So basically if I have some grapes over here and some grapes over here. Now if I take some from over here and I take the same amount from over here, so if I took 2 off of this side and 2 off of this side, my equation is still going to be balanced because this symbol means that this side is the same weight as this side. So if we take something off of this side, we're also going to have to take something off this side so that we could keep this sign here. So if we had an equation like x plus 2 equals 6, our goal is going to be to solve for what this variable is equal to. So that means I have to get rid of this 2 from both sides. So since I'm adding my 2, I'm going to have to subtract. So you have to do the opposite sign of your number. So here I'm adding 2, so I have to do the opposite or the inverse operation. So I'm going to subtract it from both sides. So if I subtract 2 from this side and subtract 2 from this side, the subtraction property of equality says that they will stay equal, which means that x is equal to 4 because I took 2 from this side, canceled out the 2's, took 2 from this side and was left with 4. So x is equal to 4. Now the same property works for addition. So the addition property of equality means that if you add the same number to both sides, you will keep your equation equal. So if I had 3 grapes over here and 3 grapes over here, they're equal, right? If I went ahead and put 2 more grapes on this side and 2 more grapes on this side, we're still going to be balanced. So that's the kind of property that we're going to be using. So if you get an equation like x minus 3 equals 9, we are going to have to isolate this variable. So we want to get the variable by itself so that it says x equals blank because we want to see what x is equal to. So in order to do this, we have to get rid of this negative 3 or this minus 3. So we have to do the opposite operation. So instead of subtracting 3, I'm going to add 3 to both sides. So if I add 3 to this side and add 3 to this side, the addition property of equality says that they will stay equal. So if I add 3 over here, the 3's cancel out because negative 3 plus positive 3 gives us 0. So that'll cancel it out, which is what we want. And then we have to add it over here. So we're going to figure out that x is equal to 12. So if we plugged x back in here, 12 minus 3, that's going to give us 9. So that's how we check for our answer. So now let's go ahead and apply these new properties to some problems. Alright, let's look at example number 1. Example number 1 says n plus 6 equals 8. Now our goal is to solve for what n is. So in order to do that, we need to get n by itself. So if we want to get n by itself, we need to go ahead and take 6 off of both sides. So since we're adding 6 to the equation, now we need to think, what's the opposite of adding? It's subtracting. So instead of adding 6 to both sides, I'm going to subtract 6 from both sides. So now 6 minus 6 gives us 0, which is what we want. We want it to be gone. And then 8 minus 6 is going to give us 2. So we know that n is equal to 2. Because once we took the 6 off of over here and the 6 off of over here, we were left with what was left over, which is n equals 2. Alright, let's go ahead and look at example number 2. It says m plus 5 equals 3. So we know that this is equal to 3 and this is equal to 3. Now, we want to go ahead and get the m by itself because that's what we're solving for. So we need to get rid of this 5. So in order to do this, since we're adding 5, we need to take away 5 because we want to cancel 5 out. So I'm going to go ahead and subtract 5 from both sides. And that's going to give me m is equal to 5 minus 5 gives me 0, which is what we want. And then 3 minus 5. Now, we are taking away a bigger number than what we have. So that means that we are going to be having a negative number. So it's going to be negative 2. So we still need to remember our rules about adding and subtracting integers to be able to make sure we get the right answer. Because that's why we did it before this, so that you would be prepared for these things. So now when we're subtracting 3 away from 5, you know, okay, it's going to be negative because we're taking away more than what we have, and we're going to have negative 2 left over. Alright, let's go ahead and look at example number 3. So it says x minus 5 equals 6. So our goal is to solve for x, so we need to get everything else gone. So since we're subtracting 5, we need to do the reverse. So we're going to add 5 here and add 5 here. So negative 5 plus 5 is going to give us 0, which is what we want because we want it gone. And now we have 6 plus 5, which is going to give us x is equal to 11. So 11 is our solution. You can always check your problems by plugging 11 back in and then say 11 minus 5, does that give me 6? Yes. So that's just a check, like if I ever say go check your homework or check your work or check your quiz, that's what I'm talking about. Plug it back in to make sure that you have the right answer. Because in this example up here, if you got 2, you could have plugged it back in and said 2 plus 5 does not give me 3. So then you would have known that there was some error there. Okay, let's go ahead and look at this last equation. It says negative 1 equals c minus 6. Now, notice we kind of flipped around our equal sign. It doesn't matter which side we're on the equal sign. I just want to make sure that you realize that that is something that happened here. So we have negative 1 equals c minus 6. So basically, we want to solve for the c. We want the solution. So that means we need to get rid of this negative 6. Now, since it's a negative 6, we need to do the opposite operation. So we're going to add 6 over here, add 6 over here. Remember, we have to do it to both sides to keep our equation equal. So negative 6 plus 6 gives us 0, which is what we want. And then negative 1 plus 6. Remember, negative 1 plus 6, same thing as 6 minus 1, which is going to give us 5. So c is equal to 5. That is our solution. If we plug it back in, 5 minus 6, we're going to get negative 1. We were correct. Okay, let's go ahead and look at this word problem real quick. It says, Orville and Wilbur Wright made the first plane flights in 1903. Wilbur's first flight was 364 feet. This was 120 feet longer than Orville's flight. Write and solve an equation. So basically, we're going to be writing an algebraic equation. So there will be an equal sign and there will be a variable. So let's go ahead and kind of see what we're looking at here. Let's look back in our equation. Now, we see that Wilbur's flight was 364 feet. So we're going to be using that somewhere in our equation. It says this was 120 feet longer than Orville's flight. Now, we don't know how long Orville's flight was. So that's going to be our variable. Now, also, notice, last lesson, we went ahead and we were reading little phrases like 120 feet longer, and we are changing it into equations and expressions. So this time, this is where the skill is coming into play. So we did it there, we did some little practice. Now this is where it really matters, is in word problems, so that we know how to write our equations so that we can solve for the right thing. So if we're having 120 feet longer than this unknown flight, that means we're going to be adding, right? If something's longer, it's adding. So if we have, we'll put an F for flight, plus 120, it's going to give us Wilbur's flight, which is 364 feet. So let's just look at our equation one more time, make sure we have everything in the right order. So this is Orville's flight. If you add 120 feet to it, you're going to get Wilbur's flight, which is 364. So our equation is set up right. Now we're going to go ahead and solve for f, which is our variable. So in order to do this, we need to get everything else away. So this 120 needs to go. So since we're adding 120, we need to subtract it from both sides. So let's subtract by 120. We're going to get it gone here. Subtract 120, and we are going to be left with f is equal to, see, we have 4, we have 4, we have 2. So now we found out that Orville's flight was 244 feet. Now to check ourselves, we could say, okay, is Wilbur's flight really 120 feet longer than Orville's? So we just plug it in, we'll check, and we'll figure out that we are right. So our solution is 244. Now make sure you have all of your notes done. Make sure if you had any questions or some of it was a little confusing, rewind it, watch it again, and if you're still confused, bring those questions in tomorrow. Now let's go ahead and do some on your own questions. Alright, you have 4 problems to solve for me. Number 1 is 7 equals y plus 2. Number 2 is negative 2 equals a plus 6. Number 3 is s minus 8 equals 9. And number 4 is negative 1 equals q minus 8. Now remember, we're solving for our variables. Do the opposite operation in order to solve for those variables, and don't forget to do it on both sides so that you can keep both sides equal. Alright, good luck. We'll see what you get tomorrow.